The software for Indy on the Rocks is uploaded onto a small handy board called the TINA board. This stands for This Is Not a Handy Board. Our software follows a state machine or a state diagram, and through the state diagram we're able to complete the challenge. I'll show you the state machine in action, and the software that we've uploaded onto the TINA board directly follows the state machine format. So as you observe, when I power on the TINA, we come up with a start screen, and this start screen is essentially all we need to start the competition. As you can see right there, you can see it say choose your strategy, and we can select which strategy we want to implement. So let's say on competition day we're confident in going for the full course including the zip line. I simply choose this and I press the start button, and then we'll be going for a start button. You'll see here that it also displays a lot of information according to which state we're in, right? And it will also cycle between telling us what state we're in. Anytime we press the stop button, so I'm going to press the stop button right now, we're able to switch between all our states in our state machine. And so from our state machine we have the initialization state. That's where we chose our different strategies we want to implement. And then the next state we have is following tape, and that brings us up to the rock pit. There's an intermediate step called climbing hill. There's this one, and essentially that's just doing the same thing as follow tape but at a higher speed. And then there's collect item, which is the process of actually collecting the items. Next we have the rock pit state, and so you'll see we're in actually a menu state right now. We have the rock pit state, and then we have the zipline state, and then finally we have the finish state. The extra states that we have are very, very useful, especially during our development process. For example, we have the test state, which helps us test various components of our machine. So for example, we have something to test the motors, the collector arm, the servos, the QRDs, the ultra-level sonic sensor, the infrared detection, and also even some algorithms to sweep the robots, and as well as activating the winch. Besides these tests, we have more settings to another state called settings, which allows us to change many variables which help define the behavior of our robot. So you can see here we have a whole bunch of variables. And these variables can all be adjusted on the fly, so we don't have to re-upload every time. So for example, let's look at follow tape Katie. Now the cool thing about this is that when I'm adjusting these variables, they actually stay permanent in the memory of the TINA. This is because we're using a library called EEPROM-X. So this external library allows us to save data onto TINA's onboard EEPROM memory. And so when we save it, we'll choose it to be 500 and something. When we turn it off, so first I'm just going to exit by pressing stop, and I'm just going to go to a random state here. When we turn it off and we turn it on again, you'll see it load up the previous saved settings. And there you saw it. It loaded our previous saved settings of the follow tape KD of around 500 or 600, I think it was. Yep, so that's how our robot works in terms of software. Thank you for watching.